session, we will learn about battery. Battery is an energy storage using electrochemical reaction, or in other words, converting chemical energy into electrical energy. It is used in off-grid PV system to store energy that is generated by PV module in daytime and distributed in nighttime or during cloudy weather. Battery is the most practical method to store electrical energy generated by PV module. What are the functions of battery? There are several functions of battery. The main are as follows. Apply for load with stable voltage and current through battery inverter in case of power intermittent happening. Reserve to anticipate difference between supply of power from PV module and power demand. Reserve to be used during cloudy weather or in emergency. And supply of power for electrical instruments such as solar charge controller and inverter. Next, let us learn some technical terms when using or operating battery. Nominal capacity, or C, is maximum energy that can be discharged from battery. Its unit is ampere hour. Depth of discharge, or DOD, is the amount of energy used by battery. State of charge, or SOC, defines the amount of remaining energy in battery and is shown in percentage. C rate is energy charging or discharging that equals to battery capacity divided by time. For example, C rate of C10 for 1000 amperes hour is 1000 divided by 10 or 100 amperes. Deep discharge is battery energy that is used below the end of discharge voltage or the voltage at the end use. Round-trip efficiency is ratio between energy discharged during use and energy to recharge the battery until it is full. Overcharge is a condition when excess current is applied to the battery at the end of charging. Cycle is one charge and discharge. State of health, or SOH, is a status of battery quality. Self-discharge rate is the decreased rate of battery capacity without being connected to load or due to internal chemical reaction. Open circuit voltage is battery voltage without load. Batteries are specified by their nominal voltage and capacity. Nominal voltage is the battery midpoint voltage or voltage measured when the battery has a 50% state of charge. Capacity is the amount of current that the battery provides in a given time. Battery usage in 10 hours means that 1 out of 10 of the battery capacity is used per hour. Lead-acid batteries are the most commonly used type of battery for off-grid PV mini-grid system, although there are newer alternatives such as lithium-ion and zinc-air. Lead-acid batteries allows deep cycle usage, so they are widely used. This type of battery works reliable for a long time, is safer and easy to use, and has relatively lower cost per cycle. Next, there are lithium-ion and zinc-air batteries. Both require battery management system for safety and to extend its lifetime due to higher energy density than lead-acid. Furthermore, the lithium-ion battery blocks usually are installed parallel to the battery rack, for which each block has a nominal capacity of 100 amperes hour at a nominal voltage of 48 volts. Whereas each bank of zinc-air battery has a capacity of 21 kWh at a nominal voltage of 48 volts. The table shows comparison of the three types of battery. There are several safety aspects to follow in battery installation and operation. Battery seal must be in good condition to prevent unnecessary oxygen loss during operation. When cleaning fluids, avoid skin contact with sulfuric acid as it's corrosive and dangerous. It can cause serious injury and blindness. Always use insulated gloves. Damaged seal must be replaced. Do not use a plastic bag to cover it. Damaged seal causes leakage of hydrogen gas and electrolyte. Explosion can happen if the hydrogen content in the air reaches 4%, while electrolyte is corrosive, so it is dangerous. Battery terminals must be covered with an acrylic board. The cables must be neatly installed and labeled with warning sign to avoid carelessness from common people. In case of carelessness, there may be risk for a short circuit to happen in the battery, causing spark and explosion. There are several things that can be done to mitigate risk. When using the battery, avoid discharging it completely. It is recommended that at least 1.95 volts per cell with a usage time up to 24 hours. Battery should not be charged with current that is too high. The higher the current, the faster the voltage decreases. Ambient temperature should not be higher than 20 degrees Celsius. To avoid terminals being corroded, battery must be fully charged every month and cycle must be conducted. The battery should not be stored for too long of a time and left in a low state of charge. Avoid direct contact between the lead, that is battery terminal, and the copper, that is the conductor. Battery bank must be charged according to specification by the three-stage charging method: bulk, absorption, and float. Avoid charging the battery with very high or maximum voltage of 2.4 volts during the bulk and absorption stages. During commissioning, it is recommended to charge the battery for at least 16 hours with a constant voltage to avoid self-discharge. Now, let us learn several aspects that affect battery performance. There are 5 of them. First is depth of discharge, or DOD. The greater the DOD is, the smaller the number of life cycles. To reach a minimum of 1825 cycles, that is approximately 5 years, at temperatures of 20 degrees Celsius, the DOD must not be higher than approximately 75%. Second is ambient temperature. The higher the ambient temperature is, the less the cycle life will be. The picture shows that the service life is reduced by half with an increase in temperature of 100 degrees Celsius. Third is swallow discharge, that is discharging battery energy with very low DOD. Can reduce charge acceptance or battery efficiency. It is recommended to use the battery effectively up to at least 30% DOD. Fourth is discharging current. The higher the current used, the lower the capacity used. Fifth is charging voltage. Use of high voltage that is above the set limit when charging the battery can cause battery overcharging. It can result in the process of gas generation, thereby reducing the amount of liquid. A battery bank consists of one or more circuits connected in parallel. One circuit consists of individual battery cells connected in series. Each produces about 2.1 volts for the lead-acid battery and varies depending on the battery technology and stage of charge conditions. When a higher voltage is required, batteries of the same capacity are connected in series until the circuit voltage of the battery reaches the required voltage, typically 48 volts DC. Meanwhile, to increase capacity, battery circuits with the same nominal voltage and characteristics are connected in parallel. There are some best practices in battery interconnection. You should only connect batteries with same technology, manufacturer, type, nominal capacity, and state of health in the battery bank. Mismatching battery capacity can cause larger battery to be not fully charged and smaller battery to be fully or even overcharged. Do not use more than 4 battery strings in parallel to avoid charging and discharging problems. The battery in the battery bank must have the same stage of charge or SOC. SOC is indicated by the voltage of each cells during open circuit condition or no load. Voltage in each cell should differ less than 0.02 volts or in accordance with the manufacturer's requirement. Overcurrent protection device must be installed on each positive and negative pole of the battery circuit. The overcurrent protection device must be determined equal to 1.25 times of possible charge or discharge current, usually L10 rate. Compensation for maximum temperature of 45 degrees Celsius must be applied in the calculation. Battery voltage, current, and temperature must be checked periodically as precaution in case of state of health decreases. The cables that are usually used are NYAF 50mm square cable is used to handle a maximum of 104 amperes. The correction factor because of ambient temperature and classification used is 0.75. YAF 35mm square cable is used to handle maximum of 103 amperes. Interconnection cable between battery cells has same length and arrangement, with parallel cable has different length that causes different cable arrangement. Now, we learn things to consider in battery installation and operation. Battery installation including assembly, rack mount, and battery space requirements must be based on IEC 624852, safety requirements for secondary batteries and battery installation. There needs to be special warning sign from the manufacturer for battery arrangement, such as arrow indicators when installing the battery horizontally and ensuring that the internal plates are arranged vertically. The battery must be installed in a stable and sturdy rack to prevent it from falling and for better cooling. The location and layout of the battery can be done in a zigzag manner with ventilation to prevent direct sun exposure. The battery compartment must have adequate ventilation to prevent high concentration of hydrogen gas in the room during charging. Lead-acid batteries can produce hydrogen gas which can be ignited due to electric bases or sparks. The battery should not be placed near a heat source or in direct sunlight. High temperatures can cause reduced surface life, leakage, and even explosion. Enough distance between the battery and the wall more than 50 cm for better airflow. Battery cells are installed with sufficient distance that is more than 1 cm so that the battery can release heat. A battery bank is installed with sufficient space between the battery arrays. Thank you for keeping up so far. Now we are near to the end of this session. But before ending it, you need to do a quiz